Hello everybody and welcome to my video on the binomial distribution. If you've never heard of the binomial distribution, it is just one of the probability distributions that we require you to know. It is a discrete distribution, and it is a distribution that is pretty popular and is used quite a bit. And in this video, I would like to discuss the four criteria that must be met for a scenario to follow what is called a binomial experiment. If the conditions are met, then you can use the binomial probability distribution to answer probability questions. So, without further ado, let's go ahead and get started. All right, so when presented with this probability scenario, we have to take a look at the four conditions that have to be met in order for that scenario to meet a a binomial probability experiment. So let's take a look at what these four conditions are. So the first condition is that there can only be two outcomes for the experiment. These are usually denoted as a success or a failure. That the trials are independent, meaning that the outcome of one trial does not have an effect on the probability of another trial. The third one is that the probability of a success remains constant from trial to trial. And then finally, that there are a fixed number of trials, and that this fixed number of trials is usually denoted by the letter n. So the probability of a success is denoted by the letter p. All right, and that's pretty much it as far as notation purposes is concerned. So let's take a look at the binomial probability density function. And the binomial probability density function is this crazy looking thing. So the probability that the random variable big X is equal to little x, which you can think of and translate little x as a number, all right, is n choose x, p to the x, 1 minus p to the n minus x. So this is the formula for the binomial probability density function, all right, and you'll notice that there are three components: the n choose x, the p to the x, and the 1 minus p to the n minus x. And it would be nice to be able to discuss what those three components mean and how to interpret those. But that, ladies and gentlemen, is left for another video. All right, so let's take a look at an example. So research shows that fans choose Spider-Man as their favorite superhero 40% of the time. Suppose that 20 people are chosen. All right, we want to compute some probabilities. So let's see if this scenario, up to the supposed 20 people are chosen, satisfies the conditions for a binomial experiment. So number one, are there only two outcomes? And the answer is yes. They either choose Spider-Man as their favorite superhero or they don't. Number two, are the outcomes independent? And the answer is yes. One person choosing Spider-Man as their favorite superhero does not have an effect on the outcome of somebody else choosing Spider-Man as their favorite superhero. Number three, that the probability of a success remains fixed. So 40% remains fixed. There's no changing of that probability of a success. And then finally, that there's a fixed number of trials. And in this case, yes, that is met because only 20 people are chosen. So the requirements for this example are met. So this does follow a binomial probability experiment. Now, this video is not intended to show actually how to use that formula or a few other formulas that are available for you. That is what technology is for, and I do have some technology tutorial videos to help you compute probabilities involving a binomial experiment. So I hope this video helps you out on what is a binomial probability experiment and if the conditions are met. So please feel free to watch my technology tutorial videos on how to compute binomial probabilities and how to compute the mean and the standard deviation of a binomial random variable. I sure hope this video helped you out. And as always, I will see you in the classroom.